R6 deals with complex numbers. Complex numbers being imaginary numbers. So, you've seen this before at some point. I is equal to the square root of 1. Now, why is that? Because you can't take the square root of a negative number. So, in order to form function with square root of negatives, then we have to make this imaginary number thing. And yeah, it is imaginary. It's not real. You can't, well, you can graph it, but not on a real axis. But we need to be able to do this to go forth with several things. So we say that the square root of negative 1 is I. And therefore that means that also I squared would be negative 1. We square both sides. Okay? So if you have the square root of, say, b, or the square root of negative b, then the negative becomes an I, and we just have the b left under the root. We get I to b. So, examples. For the first one, we've got the square root of negative 25. Well, the negative comes out as an I. And now we just have I times the square root of 25. Square root of 25 is 5. Our answer is 5I. And we do write it to where the number becomes before the I, just like you would with the variable. Okay, so here we have the square root of negative 12, so I comes out front. And that's not a perfect square, but we can deal with that. The square root of 12, we've done these before, would be 4 times 3, and the square root of 4 is 2. So we would have I times 2, the square root of 3, and we rewrite that as 2I, the square root of 3. And then square root of 13, excuse me. We can't simplify the square root of 13, so our answer is just I times the square root of 13. Okay, what if we have I to some exponent? Well, we can simplify this because I squared is negative 1. So what we need to do is get this out of the 40 in some kind of terms. Okay, so we want I squared to the something to be equal to I to the 48. Well, I squared to the 24, that would be 2 times 24 is 48. That would be the same. And so now that we've got this in terms of I squared is negative 1. And so we have negative 1 to the 24th. If we have a negative to an even power, gives us a positive. Answer is positive 1. For the next one, we've got an odd number, 23. Still got to get it in terms of I squared. So what if we said I to the 22 times I? Well, that would be I to the 22 plus 1, which is I to the 23. So it's the same thing. And now we can get that I to the 22 in terms of I squared by making it I squared to the 11th. I squared is negative 1. A negative to an odd power is a negative, so we have negative 1 times I. So our solution is just, our answer is simplified, just negative I. Let's look at 2 more of these. I to the 50th power. Again, we need to get it in terms of I squared. Well, 2 times 25 is 50. I squared is negative 1. A negative to an odd power is negative, so our answer is negative 1. And here we've got an odd exponent again, so I'm going to, and it's negative, but we need to get it in terms of I squared again. And in order to do that, we need an even number. So let's say I to the negative 20 times I. Well, that would be negative 20 plus 1 would be negative 19. So that's fair. So this would be I squared to the negative 10. That would give us I to the negative 20. Bring down the times I. So that's negative 1 to the negative 10 times I. Well, what do we do with negative exponents? We put them on the bottom of the fraction. So we have 1 over I negative 1 to the 10th power times I. What does that give us? Well, it puts I on the top, and negative 1 to the 10th, that'll be positive 1, and I over 1 is just I. Okay, so moving forward. A complex number has an imaginary number in it. So it's got a regular real part, A, your real number, and then the imaginary part, which is a number times I. So complex numbers are written in the form A plus BI. You cannot combine A plus BI, whatever the numbers are. So if it's 2 plus 3I, you can't combine the 2 and the 3I. They're not like terms. One of them is real, one of them is imaginary. That's your answer. So, in this case, we're just going to combine like terms, really. So we've got negative 2 minus 4I plus 5 plus 2I, and then we got to distribute that negative there. So minus 3 plus 6I. Combine like terms. So negative 4I plus 2I, that'll give us negative 2I, plus 6I will give us 4I. Then combine our constants. So negative 2 plus 5, that gives us 3. 3 minus 3 is 0. So our solution, our answer, simplified, is just 4I. Moving on to example 4. We're going to multiply complex numbers. Well, we're going to fool this just like we would any binomial. So first would be negative 2 times 4. That gives us negative 8. Outer is negative 2 times negative 3I, so that's plus 6I. Inner, 6I times 4, that's plus 24I. And then 6I times negative 3I is negative 18I squared, because I times I is I squared. Okay, we've got some like terms here. 6I plus 24I, that's 30I. And then we've got this I squared. Well, we have to, in order to finish this, we can't leave it as an I squared, because we know that I squared is negative 1. So we just plug in the negative 1 for the I squared. So we've got this now, plus 18. And now you can add the negative 8 and the 18 to get 30I, or 10, plus 30I, because A plus BI, we've got to have the I on the second part. So 10 plus 30I, and that's your solution. Okay, moving on. What about if we square it? Well, same thing. We're multiplying our binomials here. So we got 3 plus 4i times 3 plus 4i. 3 times 3 is 9. Then we've got 3 times 4i twice. So that'd be 12i plus 12i, which is 24i. And then 4i times 4i is 16i squared. Again, I squared is equal to negative 1. So we have 9 plus 24i minus 16. Simplify, 9 minus 16 is negative 7. And then we have plus 24i, and that's it. Let's multiply again. There's a point to this one. So 5 times, here we've got 5 plus 2i times 5 minus 2i. And you'll see why we do this here in a minute. So 5 times 5 is 25. Then we've got 5 times negative 2i. So we got negative 10i. And then we have plus 10i. And then we have minus 4i squared. So negative 10i plus 10i, that makes them go away. So that we have 25 minus 4, and I squared is negative 1. So we end up with 25 plus 4, which is 29. So we end up with a real number. It's not complex, it doesn't have an I in it, and this is going to help us in the next problem. It's called multiplying by the conjugate. If you have a plus bi, multiplying by the conjugate will give you a minus bi. So same numbers. 5 plus 2i, the conjugate is 5 minus 2i. And so we end up with a squared plus b squared, which gets rid of our I altogether. And plus there in the middle because of the I squared being negative 1. Okay, so we have a fraction. Another one of the rules that those old dudes made a long, long time ago was that we can't have an I in the denominator. So, just like roots, we have to get rid of it. How do we get rid of an I in the denominator? Well, we just discovered that if we multiply by the conjugate, which would be 3 plus 5i, then it's going to give us a real number on the bottom. It gets rid of the I. And we can't just multiply the bottom by 3 plus 5i. We have to make sure we're multiplying by 1. So we have to multiply by 3 plus 5i over 3 plus 5i. And that way we're multiplying by 1. So if we do that, we're foiling on the top. So 8 times 3 is 24. Then we have plus 40i plus 6i. So that's 46i. And then we have 2i times 5i. That's 10i squared. On the bottom, our rule says it's a squared plus b squared. So that's 3 squared plus 5 squared. Remember that the I squared is negative 1. Sometimes, rather than rewriting everything, I'll just do this. Okay? So we have 24 plus 46i, and then minus 10. And on the bottom, 3 squared is 9, 5 squared is 25. (24 minus 10, that's 14. So we have 14 plus 46i over 34. Yeah, it'd be nice to be done here, but we can't. It asks us to write it in the form a plus bi. So right now we got a plus bi over a number. So we're going to separate that. So that we have 14 over 34 plus 46i over 34. And then we have to simplify our fractions. So 2 goes into both 14 and 34, so that'll be 7 over 17. 2 goes into both 46 and 34, so that'll be 23i over 17. And that is what we have simplified. Okay, now we're going to solve equations. So example 7, we're going to solve this equation, and we're probably going to end up with an I in there somewhere, right? So let's see. We've got 2x squared. If we subtract 36 from both sides, then we have this. Let's go ahead and divide by 2. And if we take the square root of both sides, we're taking the square root of a negative number, which, guess what? Now we can do. So, goody. The square root of negative 18 will be the same as I times the square root of 18. Square root of 18's got to be simplified. That's 9 times 2. And the square root of 9 is 3, so we have a 3 we bring out, and then left with a square root of 2 underneath. So our solution set, don't forget, we want to write it like this, is positive or negative 3i square root of 2. Okay, example 8. Again, we're solving this equation, and we've got a fraction. Well, it'd be nice if we could get rid of those fractions, right? If we multiply everything, my tablet is thinking. It's not letting me write. Okay. So, if we multiply everything by 10, then that will get rid of those numbers on the bottom of the fraction, okay? So, if we multiply by 10, then we've got 30 over 10 x squared plus 20 over 5x plus 70 over 10, and 0 times 10 is just 0. Why does this help us? Well, 30 divided by 10 is 3. Okay? We end up being able to get rid of our fractions there. So that's nice. Okay, this one will not factor, so we're going to solve it using the quadratic formula. So x will be negative b plus or minus the square root of b squared minus 4ac all over 2a. Simplify that, and we've got plus or minus the square root of negative 68 over 6. And Now we know that that's allowed, right? So x is negative 4 plus or minus I times the square root of 68 over 6. Square root of 68 can be simplified. So since this one's a little bit longer, we'll go to the side and do this here. So 68 is 6 times 8, right? 6 is 2 times 3. And 8 is 2 times 4, or 2 times 2 times 2. Okay, so that's getting all those down where they can't go any further. Okay, and so what we've got is we've got a pair of 2's here and a pair of 2's here. So bring out 2 times 2, that's 4. And we're left with 68 isn't 6 times 8. It's 48 is 6 times 8. Okay, so let's try this again. 68 is actually 17 times 4, believe it or not. Okay, square root of 4 is 2, and we're left with a 17 under the radical. And on the bottom we've got 6. Now remember, we need to write that in terms of a plus bi. So we've got negative 4 over 6 plus or minus 2i square root of 17 over 6. And of course that can be reduced to be negative 2/3 plus or minus I square root of 17 over 3. And so there is our solution set. Okay, next idea here, the discriminant. The discriminant is that thing that's underneath the square root in your quadratic formula. And in case you haven't noticed, it helps us, or it determines what we're going to have. So in this case, in example 8, we ended up with a negative under the square root. Our determinant was negative. And so what that told us is that there are going to be imaginary solutions. If it was positive under the square root, we already know we're going to get real solutions. Okay? And so again, if that number underneath the square root, if b squared minus 4ac, which we call the discriminant, is negative, then we have two non-real solutions, or two imaginary solutions. If b squared minus 4a is positive, then we have two real solutions. And what if the number under the square root is 0? Well, then we don't have a root or anything. It actually probably factored. We end up with one real solution because you don't have anything plus or minus 0. You don't have anything to plus or minus there. So for these three examples, we're just looking at using the discriminant to determine the number of solutions. That's all we're doing. So negative b minus 4ac. That gives us negative 11. So guess what? Negative number means two non-real solutions. Simple enough, right? So for the next one, oh, we got to get everything on one side, so let's do that real quick. I'm going to add 6x to both sides and subtract 3 to both sides. So we have negative b plus or minus 4ac. That gives us a positive 60. Positive number means 2 real solutions. Okay, because we won't have a square root under the radical. And then this one again, need to get everything on one side, so we're going to add 9 to both sides. So we've got negative b plus or minus the square root. Oh, no. I was trying to do the whole thing. Okay, so b squared I wrote that wrong over there, didn't I? I said it, or I just said it was 60, but that's not. Okay. I'm getting my quadratic formula and my determinant confused. So over here, back on part B, that was b squared minus 4ac was 60. Okay. Is that what I had? I don't know. Okay, so over here we've got b squared minus 4ac, and that gives us 0, which tells us that there is one real solution. Okay, last concept. What a mess. Here we're going to introduce something called U-substitution. If you'll see here, in general, we've got something squared plus 36 times something plus something, or plus 35. So you've got something in the form a, or x squared, plus bx plus c. Therefore, in order to make this easier to work with, we say that u is going to be that stuff in the parentheses. Okay, 2x squared minus 3. Therefore, we have u in place of that, squared, plus 36u plus 35 equals 0. And this is something that we can solve. Okay? So, this will factor. U plus 35, U plus 1. And so we have U plus 35 equals 0, or U plus 1 equals 0, which gives us negative 35 and negative 1. Okay, well, normally we'd be done here, but we've solved for U, not for X. We need to solve for X. So, what we do is we now plug back in what we had for U. Okay? So here we've got M for U, 2x squared minus 3 equals negative 35. And then the one on the right is 2x squared minus 3 is equal to negative 1. So now we have to solve for x. Well, this isn't too bad because we can just add 3 to both sides, divide by 2, take the square root of both sides, And the square root of negative 16 is plus or minus. The negative gives us an I, and square root of 16 is 4. Okay, and so this one over here, again, add 3 to both sides. Divide by 2. And this one is the square root of 1 is plus or minus 1. And so your solution set is both positive and negative 4i, and both positive and negative 1. So you actually have 4 solutions, 2 non-real solutions and 2 real solutions. Let's look at one more example of this U-substitution, and then we'll be done for this section. Okay, I'm going to take and get everything on one side here to begin with. So subtract 3x to the 1/3 from both sides and subtract 20 from both sides. And in this case, yes, we've still got a squared and an x and a non-x. So we've got a quadratic here, believe it or not. What we've got is we've got 2x to the 1/3. X to the 1/3 is squared. That's the same thing as x to the 2/3, right? Then we have minus 3x to the 1/3. So our u is going to be x to the 1/3. So we've got 2u squared minus 3 times u minus 20 equals 0. And now we can solve this thing. This does factor. We can factor by grouping here. I'm not going to go through that. You already know how to do that. I'll go ahead and give you what it factors to be rather than writing down all that work that we've already looked at before. So here's what we factor to be. Set both of those equal to 0. So here, if we add or subtract 5 from both sides and divide by 2, u is negative 5/2, and add 4, u is 4. Okay, and now we substitute back in for u. So u was x to the 1/3. Okay, how do we get rid of a 1/3? We raise it to the 3rd power. So we have x is equal to, this will be negative 5 to the 3rd power, that's negative 125, and over 2 to the 3rd power, that's 8. Over here on the other one, again, we're going to raise to the 3rd power. And so we have, oh, that was supposed to be a 4. I just wrote the same thing again, didn't I? Okay, 4 cubed is 64. And so assuming those work, and they do, Then our solution set is negative 125 over 8, 64. And that concludes section R6.